Upon completion of this unit, one should investigate the characteristics of different optical connectors. In unit 3, we have two very important topics. One is connectors, another one is splicers to join two optical fiber cables temporarily and permanently. We have different types of optical fiber connectors and connector return losses, which is very important for back reflection, and fiber splicing techniques and fiber alignment and joint losses. Fiber splicing techniques and fiber alignment and joint losses. So this is the overall representation of optical fiber communication system. Initially, the information source is an electrical signal which will be converted into optical signal by using optical transmitter. The output of the optical transmitter is given to the optical fiber cable. Optical fiber cable will introduce some attenuation. Due to attenuation, losses will get introduced in optical fiber cable. That is the reason we are going for repeater. Repeater will consist of optical transmitter, optical receiver, electronic shaping circuit and optical transmitter. The signal received from the optical fiber cable is detected by optical receiver, which will convert optical signal into electrical signal, The electrical signal is given to the electronic shaping circuit, which will reshape the signal, electrical signal. That reshaped signal is given to the optical transmitter. This optical transmitter again convert the signal, electrical signal into optical signal. This optical transmitter will convert electrical signal into optical signal, and it is traveling through the optical fiber cable. So the optical signal is given to the optical receiver. Optical receiver is nothing but a photo detector which will convert back optical signal into electrical signal. So these are the representation of optical connector and optical splicer. These are the two important components we are learning in unit 3. And so optical fiber joints, connectorization of two optical fibers is involved in installation process. So the optical fiber joints can be categorized into two types. One is fiber connectors. First one is fiber connectors. These fiber connectors are linking them temporarily by using connectors. Two optical fiber cables will be linking temporarily by using fiber optic connectors. And next one is fiber splices, splicing them permanently by using splicers. Splicing them permanently by using splicers. Fiber optic connectors are used to link the two optical fiber cables temporarily, and splicers are used for linking them permanently. And importance of fiber optic connectors. So the connectors are used to join optical sources, optical detectors, optical splitters and optical amplifiers to the optical fiber temporarily. The connectors are used to join optical sources, optical detectors, optical amplifiers and optical splitters to the optical fiber temporarily. So they are also used to join two optical fiber cables whenever there is a requirement in establishing a long optical fiber communication link between the source and destination. So these fiber optic connectors are used to join two optical fiber cables whenever there is a requirement between long distance communication or long optical fiber communication link between the source and destination. So these optical fiber cables laid over thousands of kilometers on Earth's surface, and underneath the sea. These optical fiber cables laid over thousands of kilometers on Earth's surface and underneath the sea. These optical cables are either joined together after a few hundred kilometers or connected through repeaters to reshape the optical signal. After 100 meters are connected through repeaters after every 100 kilometers. These connectors are also called as plugs, and these connectors constitute the end of the optical fiber link. Attaching connectors to the optical fiber is called termination. Termination is used for reducing the back reflection. So the connectors constitute the end of the optical fiber link. Attaching connectors to the fiber optic cable is called termination to reduce the back reflection. And these connectors are available in different types. First one is screw-on type, and second one is bayonet, and third one is push-pull configuration. These connectors are available in screw-on type, bayonet type, and push-pull configuration type. So these connectors include single channel and multi-channel assemblies for cable to cable and cable to the circuit. These connectors include both single channel and multi-channel assemblies for cable to cable or cable to the circuit. Here the circuit is nothing but optical splitter or optical amplifier, optical transmitter or optical receiver. Requirements of a good connector. First one is low coupling loss. Requirements of a good connector is, first one is low coupling loss. Next one is compatibility and interchangeability. Third one, easy of assembly and use. Fourth one, low cost and reliability. And fifth one, low environmental sensitivity. So these are the important requirements for good connector, good optical connector. First one is low coupling loss, and second one compatibility and interchangeability. Third one, easy of assembly and use. Fourth one, low cost and reliability, and fifth one, low environmental sensitivity. Fiber optic connector coupling mechanisms. Connector coupling mechanisms are two types. First one is butt joint connector, butt joint connection mechanism or ferrule mechanism, butt joint connector fiber mechanism or ferrule fiber connectors mechanism. And second one is expanded beam or lens fiber connectors. Second one is expanded beam or lens fiber connectors. Fiber connector types are two types. First one is butt joint or ferrule fiber connectors, and second one is expanded beam or lens fiber connectors. These butt joint connectors depends upon or rely upon alignment of two prepared fiber ends. Alignment is nothing but alignment of prepared fiber ends, alignment of prepared fiber ends include, first one is fiber stripping, next one fiber cleaning, second one fiber cleaning, and third one fiber cleaving. Cleaving is nothing but cutting the portion of the optical cable. And last one is fiber polishing. To make the fiber end smooth. Fiber polishing is nothing but to make the fiber end smooth. First one is fiber stripping. Second one is fiber stripping is nothing but removing the sleeve of the optical fiber cable, removing the strength member or removing the buffer of the optical fiber cable. Next one is fiber cleaning. Cleaning is nothing but using some cotton or any. Third one is fiber cleaving, to cut the edges. Fiber polishing is nothing but to make the surface of the core, should be proper. So next coupling mechanism is expanded beam or lens fiber connectors. So this expanded beam connectors utilize optical lenses. This expanded beam connectors utilize interposed optics at the joint. That is nothing but lenses. Those are collimating and focusing lenses. In order to expand the beam from the transmitting fiber end, before reducing it again to a size compatible with the receiving fiber end. So expanded beam connectors utilize lenses in order to expand the beam. Utilizing two lenses, collimating and focusing lenses, to expand the beam from the optical fiber end, transmitting fiber end, before reducing it to again to a size compatible with the receiving fiber end. Types of butt joint or ferrule fiber connectors. These type of butt joint connectors can be categorized into two types. One is straight sleeve connector, another one is tapered sleeve connectors. First one is straight sleeve connectors, straight sleeve mechanism, and another one is tapered sleeve connector mechanism. In straight sleeve connector, the length of the sleeve and the guide ring, on the ferrules determine the end separation of the optical fiber. In straight sleeve mechanism, the length of the sleeve and the guide ring on the ferrules, determine the end separation of the optical fiber. In tapered sleeve mechanism, it uses tapered sleeves to accept and guide tapered ferrules. It uses tapered sleeve. Tapered sleeve is nothing but the shape of the tapered sleeve is like this. It uses tapered sleeve to accept and guide tapered ferrules. Again, the sleeve length and guide ring maintain a given fiber end separation.